Hello, good morning student. So I hope you have no problem doing the exercise I give on Friday. So I think we should continue with next chapter, which is higher derivative and application, chapter 17. So for today, I'm going to show you how to find turning point. Okay, turning point is maximum or minimum point of curve by using differentiation. Okay, sometimes turning point they also call stationary point. So what is actually turning point? So let's say we have a curve, right? So for this curve, this is one of the turning point. This is also turning point. Let's say this is cubic. If we have quadratic, so this is actually the turning point. So this one is maximum. And let's say we have smile graph, we have minimum. So this is actually the definition of turning point. So as you know, if we want to find the point here, okay, and if we want to use differentiation, you always know that turning point lies on horizontal line, which is gradient 0. Okay, gradient 0. Same goes to here. Okay, your turning point always lies on horizontal line, right? So I hope you get some point here. So find turning point is actually you differentiate the equation of your curve, make it equal to 0, and solve it to find your x coordinate. Okay, so let's see one example. So let's say we have one equation, y equal to x cubed minus 3x squared. Okay, find the turning point of this curve. So if the question wants you to find turning point, you have to differentiate. I hope everyone know how to differentiate already. Okay, make it equal to 0. So y equal to 0 because the gradient at turning point always 0. So dy dx is 0. So 3x squared minus 6x. Solve it. So you have 3x, x minus 2. Right? So one bracket equal to 0, another bracket equal to 0. So x equal to 0 and x equal to 2. So you have two turning point here because of this is cubic. Okay. So since you want point, so you have to find y coordinates. So how to find y coordinates? Since you have x here, substitute back in your y to find your y coordinate. So y is 0. And for x equal to 2, 2 power of 3 minus 3 to power of 2. So you have 8 minus 3 power of 2 is 2 power of 2 is 4. 4 times 3 is 12. Y equal to negative 4. Okay, so the coordinates of your turning point is 0, 0 and 2, negative 4. Okay, let's look at another example. So you have equation y equal to x squared minus 5x plus 1. Find the stationary point and determine the nature of the point. So what is the determine the nature of the point? So just now I show you sometimes you will have maximum, sometimes you will have minimum point. So nature of the point means either is a maximum or minimum. So how you gonna determine the nature? So I will show you the example here. So from the previous example, to find the stationary point, we have to differentiate your curve. Okay, this is curve. So differentiate dy dx, you will get 2x minus 5. And you know that stationary point, gradient always 0. So dy dx is gradient. So gradient is 0. Solve to find your x. So you get 5 over 2. Okay. So now you have your x. Substitute your x in your equation to find y. So we have y equal to negative 21 over 4. So our stationary point is 5 over 2 and negative 21 over 4. Okay. To determine either is a maximum or minimum, if you remember in chapter 4, if we look at the equation, this is quadratic, it's a positive graph, it's a smile graph. So it's a minimum, right? Minimum point. This should be a minimum point. Another method to find minimum point in chapter 4 is by using completing the square. But since now you know how to find minimum point using differentiation, it's easier to find using differentiation. So, just now, how to determine the nature of point using differentiation? Let's say we have cubic graph or whatsoever graph, and we cannot determine by using guessing like in quadratic. So what you have to do is we use second derivative. Okay, so what is second derivative? Second derivative is actually you differentiate again one more time. So just now we already differentiate once, this one, right? Okay, now we're gonna differentiate again the equation one more time. We call it second derivative. So the symbol of second derivative is d square y over dx square. Mean we differentiate y one more time with respect to x. So now from here we have dy dx equal to 2x minus 5. So d square y over dx square is 2. Okay, differentiate to x minus 5 is 2. It's positive, more than 0. So if you look at your textbook, I believe all of you have textbook. Okay, this is actually the formula. Okay, if d square y over dx square more than 0, then s is the minimum point. However, if d square y over dx square less than 0, then it's a maximum point. So, just now after we do second derivative, we get 2, which is more than 0. Therefore, this is minimum point. Alright. So we already answer all the question. We already find the stationary point. Only one point because of this is quadratic. Determine the nature. We do second derivative. We differentiate again. Then we check either is more than 0 or less than 0. If more means minimum point. If less, that means maximum point. So our answer is this and this.